Okay, good evening. Can you hear me? Hello. Okay, good evening. Can you hear me? Okay, thank you. Okay, so we will start our today's session. So basically today is our second day, and I hope all of you already get all of materials for first classes. Okay, mainly practice code or recorded session you also get. Okay, so after completing the 3 hours training session, then you talk about the problem solving class. Okay, so let me share my screen. Okay, can you see my screen? Is it visible? Okay, I hope can you see my screen? Yeah. Okay, so basically today's session I discuss about that this topic, how we can easily filtering and displaying the satellite images. Okay, such as Landsat, Sentinel, or MODIS. So this type of satellite images, how we can easily filtering and exporting this type of satellite images. We also discuss about that, and how we can easily create the different types of satellite composite. Okay, or band combination, how we can easily create. Okay, as well as how to export satellite images, Landsat, Sentinel, or MODIS, as well as how we can easily import any data set in Google Earth Engine, or filter or reduce or clip and display the raster data in Google Earth Engine. We'll discuss, and also discuss about the time series analysis, how we can easily create time series analysis, and also discuss about that how to export any shape file from Google Earth Engine, and also discuss about the annual image composite. Okay, or monthly image composite, how we can easily create. I also try to discuss about that. Okay, so let's go ahead and discuss about that all of topic. And if you have any question or any confusion anytime, you can simply ask me the question, no problem. Okay, so first of all we discuss about that image collection. Okay, so previous class I discussed about that 5 types of data we can use in Google Earth Engine, mainly geometry, feature, feature collection, image, and image collection. Okay, these 5 types of data we are always using in Google Earth Engine. Okay, and we can use different types of function to handle this type of data in Google Earth Engine. So previous class I discussed about the feature and feature collection. Okay, how we can easily add the different types of features, mainly boundary, shapefile, this type of things. So today's session we discuss about that image collection. Okay, so image collection is one kind of data type in Earth Engine. Okay, it can be any kinds of image collection. It can be Landsat image collection, or Sentinel image collection, MODIS image collection, or any others image collection. Okay, not only for that Landsat, Sentinel, any image collection. Okay, so this image collection is one kind of data type in our Earth Engine. Okay, so when you filter, how I can filter the image collection? Okay, so how I can filtering this image collection, it's a question. So how I can filter my image collection? So suppose I have 1000 images, okay, in my collection. 1000 images I have. So this 1000 images I want to filter. So how I can filter? So when you filter this image collection, this filtering process is different some factor. First factor is your ROI. ROI mainly region of interest. Okay, basically where you need the image. Okay, this is the one factor where you need the image. Okay, this is the one factor for filtering when you filtering your satellite image collection. Suppose I have 1000 images for the whole world. I have 1000 images for the whole world, but I don't need for the whole world. I need only for the specific boundary or a specific point or a specific location. So this is my ROI where you need the image. So this is the first factor for filtering. Second factor, it's called the image metadata. Okay, image metadata, mainly image properties. Suppose I need the image only less than 1% cloud cover, okay, or 10% cloud cover, 5% cloud cover. So this is the another factor for filtering for image collection. Image metadata, suppose I need the image less than 1% cloud cover. So cloud cover is one kind of image properties or image factor, okay, or image metadata. So this metadata I want to filter. So this is another factor for filtering. And final factor is that it's called the um, date. Okay, date mainly when you need the image. Okay, it can be any specific date. Okay, suppose year of 2021, month of January, February, or summer season, rainy season, or any specific time period when you need the image. So any image collection in Google Earth Engine, when you filter, we filtering using this three factor. First factor, where you need the image. Second factor, image metadata. Okay, image metadata. Suppose I need the image, it will be not more than 1% cloud cover. Okay, it's called the image metadata or image properties. And final, another factor is the date when you need the image. Suppose I need the image summer season, rainy season, or any specific time period. So always any image collection, it can be Landsat, it can be Sentinel, it can be Modis, any image collection, when you filter, just we follow these three factor. And for the three factor, we need to use three different function. Okay, suppose where you need the image, so for that I need to use a function. This function name filter bounce function. Okay, it's one kind of function. This function mainly filter your study area. Okay, it's called the filter bounce function. So when you filter image metadata, then I need to use the another function. This function called filter metadata. Okay, this is the another function. Filter bounds, it's the another function. And when you filter a specific time period, we need to use the another function. It's called the filter date function. Okay, so we need the three function: filter bounds function, filter metadata function, and filter date function. Not only for that, if you want, you can also search here this type of function, then we can get lot of description how it will be work. All of those we can easily get. Suppose I simply search here filter bounds function. I simply search here, you can see. So now I can get all of details about this function. If you check in here, then we can easily get all of details about this function. So ee.feature collection, it's a filter bounds function. Also you can say filter bounds function. So filter bounds function, if I just click, you can see. So you can get all of description about that. Okay, for the filter bounds function, basically this function shortcut to filter a collection by intersection with your geometry, mainly your shapefile or your point or your polygon. Okay, filter a collection by intersection with your geometry. So if you simply search here another function, suppose filter metadata, okay. So this is the function about the filter metadata. So shortcut to a filter a collection by metadata or image properties. And you can see this type of argument I have for this function: name, operator, value. What is the name? Name mainly your collection features or your property name. Okay, property to filter. Which property you want to filter? This is the name. Then operator, it can be less than, greater than, not equal, not less than, not greater than. This type of operator we are used for the different time. And also again the value. Value is mainly your number. Okay, suppose less than 1%, 2%, 5%, like that. And finally, another function, it's called the filter date function. So if you check the filter date function, so this is the filter date function. So start and end. Okay, so simply put the start date and end date, and then we can simply use the filter date function. So this is the way. Basically, we are just use these three function: filter bounds function, filter metadata function, and filter date function. So let's go the practical example. So now I simply import a image collection. Suppose I simply click on my data catalog. So this is the data catalog. So from this data catalog, we can easily access all of image collection: Landsat, Sentinel, MODIS, or high resolution imagery, different types of geophysical data, train data, land cover data, cropland data. Okay, it provides a lot of data set. Okay, if you click on here Landsat, then we can easily get all of Landsat image collection. You can see Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So different time period, we find out the different Landsat collection. Click on the Sentinel, then I can get all of Sentinel image collection for Sentinel 1 SAR data or Sentinel 2 data. So all of Sentinel data you can easily get. You can see Sentinel 1, Sentinel 2, okay, then Sentinel 5 Petrochemy, Sentinel 3 ocean color, land data we also get. So all of data we can easily get from here. Also click on the MODIS. So now we can easily find out all of MODIS product, MODIS daily product. Okay, different types of MODIS data we can easily find out in here. So now how I can use this type of data? Suppose I want to show the one example for Landsat. So if you check, this is the Landsat image collection. Okay, Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So all of Landsat collection are the same process when you filter any image collection. Landsat 9, Landsat 8, Sentinel 2, any image collection, when you filtering, just apply this three factor. Where you need the image metadata, and date. We are just use three factor and filtering any image collection, All of image collection are the same process, not different, same process. So I will show you the one example for suppose Landsat 8. Click on here. And here I find out this type of surface reflectance, also get the top of atmospheric reflectance and raw image. So basically top of atmosphere it use, and this type of image collection is already atmospherically correction already done, as well as also enhancement. So all of correction is already done when you're using the surface reflectance or top of atmosphere. This type of image collection don't need to do any kinds of correction because this type of correction is already done. Okay, so I'll show the example. Suppose top of atmosphere, just I click on here. So now I can get all of information about this image collection. So you can see this is the image collection, and this image collection is available between this time. It will be start from 2013 0318 to present time 2025 0720. Okay, this is the last time about that, and it also updating, as well as this data set is the provider is that USGS and Google. And you can see this is the Earth Engine snippet. Okay, this is the ID, this is the directory of this data set. If you check this directory, basically it show the Landsat 8 collection 2 tier 1 top of atmosphere, TOA, top of atmosphere. So this is the directory. Okay, this is the directory of this data set. Basically this data set is stored. Okay, this is the directory, or this is the path. This path is stored this full image collection. Okay, so now I just simply copy this directory, just copy and import in my code editor. Just simply import, in my code editor. Okay, so now you can just put a variable name. you can put any name as a variable. You can put any name. Suppose I put the name is L8 and equal. So now what happened? So this is my image collection, okay, and this image collection I just store it in a folder. Suppose I put the folder name is L8. So now I want to check how many images are available in my collection. How many images are available in my collection? I want to compute. So for that, just use the print function and call the L8 and use here the size function. So now this size function computed how many images are available in this L8. Basically L8 is stored the full image collection. Okay, so now run the code and check what happened. Just I run the code. So now it's number computing. So now it show the total image collection. Okay, total image collection from year of 2013 to 2025. Okay, all of years, how many images are available for the whole world between this time period. So now it's computing total number of images in a collection. Okay, so here again, so you can get the very large number. Okay, so this is the full image collection. Okay, full images. So we find out this is our large number of image collection are available between this time period 2013 to 2025 for the whole world. So now this image collection I want to filter. Okay, this image collection I want to filter, and how I can filter? Just I use this 3-factor and filtering my image collection. So let's go try to filtering. So first of all, where you need the image. Okay, I need to define where I need the image. So for that, if you want, suppose if you want, you can take the rectangle. If you want, you can also take the draw the shape or polygon. If you want, you can also take the point. Suppose I need the image for this point. Just I take this point. Suppose for this point I need this image. So I simply import a geometry. Okay, import a geometry, and now I want to need the image. I need the image only for the geometry. Only for the geometry I need the image. So here I need the image. I define my study area. I define my ROI. So this is my region of interest. I need the image for this study area, and it is stored in the geometry. So you can put any name. I put the name, suppose it's my ROI. Okay, so I need the image for my ROI. So now just you need to use a function, this function called the filter bounds function. Okay, so filter bounds function I need to apply because I need the image for this study area, not for the whole world. So let's go try to apply this function. So for that, just take a variable. Suppose I put the variable name is filter region. Okay, and call the L8 because this variable is stored the all of images. Okay, for the whole world, but I don't need for the whole world. I need only for this point. Only for this point I need the image. So just I call the L8 because L8 is stored the all of images. Just I put the L8, this variable L8, and apply the function. It's called filter bounds function. Okay, and filter bounds, if you check what is the argument about that. So if you check in here, filter bounds, this argument is geometry. Okay, geometry, basically it can be point, it can be line or shapefile or polygon, anything. So in this case I take the point. Okay, I put the point name is the ROI. So I need the image collection for this geometry. I put here this geometry is ROI. Okay, so now let's check how many images are available only for this study area, only for this ROI. So for that I simply copy this variable filter region and compute how many images are available only for this study area. So let's go try to run the code and check. So we find out the 543 images are available for this study area. For this point, we find out the total 543 images. Okay, but I don't need all of images from 543. I need only for those images which image is less than 1% cloud cover. So this is my argument. I need the image which image will be not more than 1% cloud covered. So further we need to use the function filter metadata function. Okay, so let's go try to apply this function. So take a variable. I put the variable name, suppose filter metadata. You can put any name as a variable. And now from 543 images. So these 543 images stored in this variable. Just I copy the variable name and paste here. And then apply the function filter metadata. Okay, filter metadata. And now if you check what is the filter metadata argument, so simply search here this function filter metadata. So if you check this function, we need the name, then operator and value. So name mainly, what is the name? Name is the property name. So which property you want to filter? So if you check the image information, so here we find out the image properties. Okay, so I want to use suppose cloud cover. Okay, cloud cover. I want to filter the cloud cover less than 1% cloud cover. Just I copy the property name and then paste here. Okay, this is my property name. Then I set the operator. So if you check operator, it can be greater than, less than. So I need to use this less than. So just I copy the property operator less than. Less than and set the value 1. So now what happened? So now from this 543 images, I choose only for those images which image will be not more than 1% cloud covered. So now let's check how many images is the less than 1% cloud cover. I want to check it. So for that, just simply copy this variable. And now I want to check how many images are available and run the code. So now it's computing how many images is the less than 1% cloud cover. We find out the 86 images are available. And this 86 image is less than 1% cloud cover. Okay. And finally, what is the time duration for this 86 images? This time duration is year of 2013 to 2025. But I need only for the specific time period. Suppose year of 2024 or summer season, rainy season, or any other specific time. So now we try to apply a function, this function called filter date function. Okay, so let's go. So for that, just take a variable. I put the variable name, suppose filter date. And now from 86 images, I choose only for those images which images are available in year of 2024. Okay, so for that, I simply copy the filter metadata because this variable is stored 86 images. So just I paste here and then apply the function filter date function. Okay, and define my date. Suppose year of 2025, 1st January. From year of 2025, I put suppose what is the last time. If you check, this time is that 0720. So I put suppose 0720. So I need the image between this time period. I simply put the start date and end date. So now let's check how many images are available in this time period. So just use the print function and call the filter date and apply the size function. So now it's computing how many images are available in my specific time period. So we find out in this time period total 4 images I find out in here. Okay, so this is the process for filtering. When you filtering any image collection, it can be Landsat, it can be Sentinel, it can be Modis. Just apply this 3 step. First step, where you need the image. Okay, second step, how. Suppose I need the image less than 1%. Sometime less than 1% cloud cover image is not available. Suppose you want to work for riverbank or coastal area or any place where there is no image less than 1% cloud cover, then you need to increase the cloud level. Suppose 5%, 10%, okay, 50%. Okay, then you need to increase this cloud level. So because for your study area there is no less than 1% image, then you need to increase the number. Okay, and then we just simply apply the time period, start date and end date. Then we find out the final output. Suppose we find out the for this place we find out the 4 images. Okay, this 4 images is available between this time period. This 4 images is the less than 1% cloud cover, and this 4 images is available on my study area. So now I want to check all of information about this image collection. So this 4 images, I want to check all of information for this 4 images, when it will be acquisition date, all of those I want to check. So for that, simply print and call the filter date this variable, because this variable stored these 4 images. So now let's check, we try to check it. Okay. So if you check all of image information, you can see first of all type is the image collection, because more than one image, it's called the image collection. Image collection is one kind of data type. Then you can check all of images have this type of band, b1, b2, b3, b4, b5, b6, b7, b8, this type of band. Okay, and you can see the all of image information. So this is the first image, second image, third image, and fourth image. So now we want to check all of information about this image. Just click on here the first image. We can get the properties. For the first image, properties I want to check. So you can see what is the cloud cover. This is the cloud cover. All of properties. This is the tier 1, collection number 2, and data acquisition date. This is the data acquisition date 2025-01-11. So this is the time period for acquisition date. So all of information we can get for this image, first image. Okay, then second image, just click on here and then click on the properties. Then we can get all of information about the second image. Then third image. Okay, same as for fourth image, we can get all of information. So now I want to display, suppose I want to display the first image for my study area, second image I want to display. So now how I can display this type of image in my map? So for displaying this image, yes. So for displaying this image, if you check, click on here, we can get a ID. You can see for the first image, we get a ID. So this is the ID of the first image. So let me just decrease the zoom. You can see this is the first ID. Okay, this is the first image ID. Okay, this is the first image ID. Same as if you check for the second image, this is the second image ID. So every image have a ID. Okay, so when you display the image on the map, we need to copy the ID. Suppose I simply copy the ID of first image. So this first image, I simply copy the ID. This ID I just copy. Okay, and then I need to use it. Because I want to display the first image. So now just simply paste here. Okay, this is the ID. So this ID I simply paste in the code editor. Okay, so now I want to use a function, which function stored the path of image. So if you check the function ee.image, so ee.image, so basically image is one kind of data type. We already know about that. Image is one kind of data type in Earth Engine. Okay, so I want to apply this ee.image, this function. So let me find out this function ee.image. Where is it? Yeah, so this one, ee.image. So ee.image is, it's one kind of data type in Earth Engine, and this is the path, this is the ID, this is the directory of my image. So this image I want to just, I apply this function ee.image, and then I just use the parenthesis and then paste the ID. Okay, so you can see an object to represent an art engine image. Okay, so now I just use this function. You can see a string art engine asset ID. Okay, so it can be ID. So just I copy ee.image this function, and then I just apply in here, just paste, and then use the parenthesis and also close this parenthesis. Okay, so now ee.image, so this is the one kind of data type, and then I define the ID of my image. I just define the ID of my image, or it can also say about that it's a directory or path of this image. So now after define the directory, we simply take a variable. Suppose I put the variable name is I put the name, any name, I put the name, suppose img equal. So now this image is stored in this variable. Okay, so I want to visualize, I want to add the layer. Okay, so just apply the function map.add layer, and I want to add the layer for this image. Just I copy the img and paste here. Okay, so now run the code, and now it also added the layer. If you check, it also add the layer, and we find out this type of images in here. Okay, but this image, it look like that without visualization. So now we try to create the band combination. Okay, different types of band combination we are using in remote sensing, such as natural color, false color, agriculture, shortwave infrared. So different types of band combinations are available. If you simply search on the Google, suppose band combination for Landsat 8, just on the search, then we find out that lot of band combination. Well, okay, so we are just use different types of band combination to identify different types of features from satellite imagery. So if you check this type of band combination, it's called the natural color 432. This is the band combination 543. Okay, this is the band number 543, near infrared red and green. Okay, then 764. Okay, then 652. So different types of band combination. So now how I can add the band combination in my satellite images. So for that, if you just click on here, layer, and click on the layer properties, and you can see the 3 bands. So now it show the band 1, band 2, band 3, but I want to add red, then green, and blue band. Okay, so I set the RGB. So red, green, and blue. So now it added the red, green, and blue. And if you check the range, it's one kind of reflectance value. Okay, so it default show 0 and 1, but when I increasing the stressing level, you can see different types of stressing level are available in here. Stressing level 90%, 80%, 100%, 3 sigma, 2 sigma, 1 sigma. So we are use different types of stressing level to more better visualization of our images. But 98% is standard. 98% is standard stressing level. So I just use the 98% stressing level. Then it automatically changes the minimum and maximum range of reflectance value. So now I can find out the reflectance value 0.03, 0.2 when I apply the 98%. So I just keep it and I apply the red, green, and blue, and then apply. So now this visualization is set in my images. So we find out this type of images look like that. Okay, and this image information we can easily get from this property. For the first image property, if you check the features, first image, and click on the properties, then I can get all of information about this image acquisition date, image cloud cover, all of information you can easily get for these images. Okay, so this is the visualization I simply add. So this visualization I want to import in my code editor. I want to import. So for that, if you check the import option, you can see the import option. Just I click on the import, a new line of code will be added in my code editor. This line is added. So this is the visualization parameter. Okay, just I copy this variable and paste after the object. Okay, this is my object, and then I put the visualization parameter. Okay, so now this visualization parameter is set it with my images. So now if I run the code, you can see we find out this visualization which I set natural color. Okay, we find out this type of image collection because I simply set this variable. This variable is stored this visualization red, green, and blue. Okay, I set it with my image, and if you check it show the layer 1, but I want to set a name. I want to set a name. So for the name, just after visualization parameter, just set the name. I put the name, suppose natural color, or you can put any name. So now it will be set as a layer name. You can see natural color. We find out this type of visualization. Okay, so this is the one way to add the visualization. Suppose I want to add the another layer to display this band combination. Suppose this band combination. Okay, 543 543 I want to add. So let's go try to do it. So for that same process, just click on here and add, suppose near infrared 5, then 4 red, and 3 green. Okay, and then I just apply, or if you simply click on the stressing, suppose I keep the 98% stressing level, and then apply. So now it's added the another band combination. We find out this type of band combination, and this band combination I want to add as a layer. So for that I also click on the import. If you can check, when I click on the import, when I click on the import, a new line of code is added in my code editor. Okay, it added. So let's go, we try to add the layer for this visualization parameter. So for that, just I take the again map dot add layer, and then I call the img. Okay, and then I copy this variable name and paste. Okay, I put the layer name. Suppose I put the layer name is, it's a color infrared. Just I use the same name, or you can put any name as a layer. So just I put here it's a color infrared. So now run the code. So now it added the 2 layer. If you check, it added the 2 layer. So this is my image. It's a natural color. We find out this is the another. It's the color infrared. We try to add the another band combination. So let's do, I want to add the another band combination. So for that, how I can do? Same process, just click on the setting layer properties. Suppose I want to add this band combination. It's a, suppose this one 652 652 I want to add. So for that, simply put here the 6, then 5 and 2. Stressing I keep 98%, and then apply. So now it will be added this band combination, but I want to import. So you can see when I click on the import, a new line of code will be added. Okay, so just I copy and add a layer. I add a new layer. So same process, just I add the new layer. So map dot add layer and call the img and paste this visualization parameter and put the layer name. Suppose it's called the agriculture band combination. Just I copy, I use the same name. So now run the code. So now it's added the 3 layer to display the different band combination for our images. So you can see this is the natural color, this is the color infrared, and this is the agriculture. So this is the way to display the satellite images using different types of band combination. Suppose now we are just showing only for the first image. So you try to show suppose second image. You can see that this is the second image. Same process, just copy the ID, and others are the same process. Suppose you want to display third image, same process. You want to display for fourth image. So same process we are just applying, and then we display our images. So you can see this image acquisition is that. Okay, so same process, just apply and display the different images. Okay, So anyone, any question you can ask me for this code for displaying the satellite images. And it's called the single image. We are not creating the composite, we are just use the single images. So further also discuss about the composite. Please, any question? Yeah, please.
Yeah, these bands, what are they stand for the different bands? Is it band 1, band 2, 3, 4, 5? Is it kind of agricultural, or is it sectoral based, or what are they based on?
Okay, this is the band. If you check this information, you can see the bands. So you can see the coastal aerosol B1, blue band is name is the B2, green is the B3, red is the B4, near infrared is the B5. Okay, so this is the band name. Okay, and this is the description about this band. Okay, so this type of bands we are just using here, and then we create this type of visualization. Okay,
like for example P5, is it kind of is it showing a different a specific
okay, so now we discuss. Okay, so we are just
or
so now it creates the combination. If you check, we can create the 3 bands and make the combination. Suppose I want to show only for the single band. Suppose just I click on here, so I want to display only for the single band, suppose V5, near infrared band. So now apply. So now it display only for the near infrared band. Okay, only for the B5 band. Suppose I want to display only for the blue band and apply. So now it display only for the blue band. Okay, this is the blue band. And when you create the combination, set combination, basically 3 bands make a one combination. Suppose in this case red, green and blue make the one combination. Okay, and if you check this, okay, if I think you also read this article, then you also get the more better idea about that band combination, how it will work for the different band. Okay, and if you check this, it's called the natural color. So when I put the red, green and blue, it replicate close to what our human eye can see. Okay, mainly healthy vegetation show as a green, unhealthy flora is the brown, urban feature appears the white and gray. And when I apply this type of band combination, then vegetation show as a red color. Okay, vegetation show as a red color, water body show as a dark color or black color. Okay, and also you can see when I apply, so it show the another colors. If you check when I just use it, so then it show this type of thing. Okay, this is the geology features. So this is the band combination for the identify different types of geological features. Okay, or lithology features or geological formation, as well as you can see the bathymetric. So I want to identify some bathymetric features, then I just use this type of band combination to identify different types of bathymetric features or suspended sediment in the water. Okay, also you can see the vegetation index, NDVI. So further let's discuss about the NDVI, how we can easily compute it. Okay, or moisture index. So different types of index we are using remote sensing, and satellite image is stored this type of information. Okay, so this type of information, satellite image is stored Landsat, Sentinel or MODIS. It is stored different types of wavelength. Okay, suppose it's B1, B2, coastal aerosol, blue, green, red, near infrared or short wave infrared. This type of information is stored by satellite image. And if you want, you can also, okay, just a minute, I will show you that. So from the resources, you can also read this book. I hope it also get the more better idea. Then you also get the, okay, remote sensing and GIS integration. This book it can also try to read. Then I hope you also get the more basic things about the satellite images and how it will work. Okay, so from this website, simply click on the resource and then download this book. Okay, then you can get some basic theoretical part. Okay, how satellite image, how electromagnetic radiation or wavelength. So this type of definition you can easily get from this book, no problem. Okay, so now we set this type of band combination and we can get this type of result. Okay, for this point, but now I want to display this result as a polygon. Suppose I have a shape file. Suppose I have a Dhaka city shape file or any other study area I have. So now I want to work with that same process. So for that, I just simply import my study area. So previous class I discussed about that how we can easily import the shape file. Okay, suppose here I already imported my shape file. Suppose I want to work for this. Okay, let me open. Where is it? Suppose this is the Dhaka boundary. Suppose I need the image for Dhaka boundary. So this is my Dhaka boundary shapefile. I already uploaded in the asset tab. So I want to use this boundary, and then I want to get the satellite images. So for that, simply click on the import. Okay, it will be imported. You can see it show the table as the default variable name. You can use any name. Suppose I put the name is Dhaka. So now I need the image for Dhaka. Okay, so for that I simply change. Suppose filter bounds with, I put the variable name Dhaka, because now I want to work for the Dhaka boundary. So Dhaka boundary is stored in this variable. So just I simply put the change the geometry. My geometry is now Dhaka boundary, and others keep the same. Okay, others I keep the same. So now if I run the code, suppose I just run the code. Now it show the information for, okay, I think some networking issue. Just I run again. So now we can get the result for Dhaka boundary. Okay, so if you check, so now I find out that 6 images. Okay, I find out the 6 images for my Dhaka boundary. I find out the 6 images is available, and I can get all of information about these 6 images. Okay, you can see this information basically for the Dhaka city boundary, not only for this ROI, because in this case I just use the filter bounds with my study area is Dhaka. Okay, so now let's check. I simply comment all of those lines because this is this ID. Okay, so this ID is only for this boundary, but when I work with Dhaka city boundary, it give me new ID. Okay, it's give me total 6 images for my Dhaka city boundary. So I want to use, suppose I want to use this images for the Dhaka city boundary. So simply copy, just copy this ID. Just I copy this ID. And same process I just apply to display this image in my Dhaka city boundary. So for that, just I take a variable. Suppose I put the variable name is that image, and apply ee.image. Okay, and paste this ID. Oh, sorry. Just copy this ID. So this is the ID. This ID I copy and paste here. So now I display this ID. So for that, just add a layer, map.add layer, and just call this object image. So now run the code. So now it added the layer. You can see it added the layer, but not focus my study area. So for focusing our study area, we are use a function. This function called map.center object. Okay, so this function help you to focus on your given study area center. So I want to focus on the Dhaka boundary. Just I copy this variable name and paste here. Okay, and then give a zoom level, suppose 5. Now run the code. So now it directly focus on my given study area. Okay, you can see it focusing. And I find out this type of images. Okay, I find out this type of images look like that. Okay, this type of image I find out in here. So now this is my image. Okay, this image I find out, and it also cover my study area Dhaka boundary. Okay, if I just add the layer, suppose I want to add the layer of Dhaka boundary, I simply add the layer. So for that same process, I just use a layer, suppose map.add layer, and call the Dhaka, because this is my Dhaka boundary. I want to add, and then check what happened. Just run the code. So now it's added the 2 layer. So you can see this is my study area Dhaka. This is my shape file, and this is my image. So this is my boundary, and this is my image. So it's the overlay. You can see it's overlay with my images. So now I don't need for the outside of my boundary. I need only for this study area. I just simply clip. So just I clip with my shape file. Okay, this is the image, and this is my boundary. So just I simply clip, then I can get the image only for my boundary. So let's go try to apply the clip function. So for clip, just use here the dot clip, and then I want to clip using this boundary, using this Dhaka city boundary, and Dhaka city boundary is stored in this variable Dhaka. Just I copy and then paste here. Okay, so now this image is clipping with my boundary, and now if I just run the code, I got the image only for my boundary, only for boundary. Okay, hence I can get the image only for my boundary. So now I want to add the band combination, same process. So just I click on here and add the band combination, different types of band combination. Suppose I add here red, then green and blue. Stressing keep by 98%. So then apply. So now it's added this type of natural color. Okay, natural color image we find out. Okay, and then I want to click on the import. When I click the import, a new line of code will be added. Just I copy this visualization and paste after the object name. Okay, now this visualization is set with my code, and I want to add the layer name. Suppose Dhaka true color. So now we find out this type of. So same process you can also apply and add the different types of band combination also. So this is the way when you work with your shapefile. Suppose this is my study area, this is my study area, and I need the satellite image for my study area. So just apply the same process and we can get the satellite image for my study area. So this is the satellite image. So now I can easily use it to make the different types of remote sensing analysis, such as land use, land cover, or NDVI, vegetation analysis. Everything I can do for my boundary. Okay. Okay, anyone any question you can ask me. And it's called the single date imagery image, because in this time I just show the image for this time 2025 8 February. Okay, 8 February. So this is the acquisition time. So for this acquisition time I simply get this imagery. It is single date imagery. But if you want, you can also create the composite. Suppose image composite, and composite when you need. So when you work with big study area, then we need the composite. When you work with the big study area, suppose I want to work with for whole country boundary of Bangladesh, I need the satellite image for the whole country boundary of Bangladesh. Then one tiles or one image is not enough to covering the whole country boundary of Bangladesh. Then I help of composite. Composite basically, suppose I have 10 images. Suppose I have 10 images. So these 10 images I simply create the composite, mainly combine. And this combine we can create different combine. Suppose we can create the median composite. Okay, median composite. We can create the mosaic composite. Sometimes we also use here the mean composite. Okay, sometimes mode composite we also use sometime, but not mass. Mode composite. So we create the different composite, okay, to cover the whole big study area. Because big study area, one tiles or single date image is not fully fill up the all country boundary of Bangladesh. It is not fully fill up. So that's why we need to create the composite for the big study area. Suppose I'll show the practical example. Suppose I simply import the Bangladesh district boundary. Suppose this is my, just I simply import. So I put here the BD. Okay, BD. So BD is stored at the Bangladesh boundary. So now I want to add the layer. Suppose map dot add layer, and I put here the BD just on the code. So now I can get the boundary. Suppose this is my study area. So I need the satellite image for the whole country boundary of Bangladesh. Okay. So whole boundary, I need the image. So for that, what can I do? So for that, I simply change the filter bounds. I want to filter bounds with BD. So now BD is my geometry. So just I put at the BD. Okay. And now run the code. So now it display how many images are available for the whole country boundary of Bangladesh. We find out. If you check, we find out that total 38 images. Okay. This 38 image is the less than 1% cloud cover. Okay. Because you can see we are already filtering we take the less than 1%. Okay. And this 38 image is available between this time period 2025 to January to 0720. So this time period is available, this 38 images. So now for full Bangladesh, I have total 38 images. Okay, you can check all of images. You can see all of images. You can also find out in here. So all of images, total 38 images. But this single image, this suppose I want to use this ID. This ID is not fully fill up my study area. Is not fully fill up my study area because it's a big study area, not a small. But we already see, suppose for the Dhaka boundary, we can easily fill up. We can easily fill up with a single images, single date images we can easily use, and it's fully fill up our study area. Okay, we already check it. But when you work with big study area like whole country boundary of Bangladesh or any big study area, then it's not possible to use a single date image and fully fill up your study area. Then we just apply the composite. We are just applying the composite. So in this case, I have total 38 images. So just for the biggest study, I have total 38 images. This 38 images, I just make the combine using median composite or mosaic composite. So now what is the median? What is the mosaic? So if you simply search in here, median function, simply search. So median, you can see the median. Okay, just click on here. So this is a function. It reduces an image collection by calculating the median of all values at the each pixel across the stack of all missing bands. Okay, bands are matched by their name, such as B1, B2, B3, like this name. So when I apply the median, it calculating the median value of all values, of all images. Suppose I have total 38 images. When I apply the median, then it calculates the median of all values at each pixel across the stacking. Okay, so just I apply the median and then compute the median pixel value and create the composite. So let's go how I can do it. So for that, just take a variable. Suppose I put the variable name is that median image. Okay, and I want to create the median image using 38 images. So just I call 38 image is stored in a variable. What's the variable name? Filter date. Because filter date, this variable is stored 38 images. So just I call the filter date and paste here. Okay, and then apply the median function. So now what happened? This filter date, this variable is stored 38 images. When I apply the median, then all of images calculating the median pixel value and create the stacking by matching their band's name. Okay, so now if I just add the layer, if you check what happened, just add the layer, map.add layer of median image and run the code. So now I can easily find out this median image is covering my study area. Whole country boundary of Bangladesh is covering. So you can see it's covering. It create the combine all of total 38 images, all of 38 tiles. And now you can see these tiles is covering my study area. Okay, so I don't need for the outside of my boundary. So just I apply the clipping. Just I clip with my boundary. So this is my boundary. This is my boundary. And this is my median image. So just applying the clipping function. Okay, so let's go try to apply the clip. So just put the dot clip, and I want to clip using this boundary, and this boundary is stored in a variable. This variable name is bd. So just I copy the bd and paste here. So now run the code. So now we can get the image only for our boundary area. So you can get this type of imagery, and now it's fully cover my whole study area in Bangladesh. So now I want to add the visualization. Same process. Click on here. And set the band combination. Suppose I set the band combination short wave infrared 1, then near infrared, and then suppose blue. Stressing 98% I keep. So it computing the stressing value. Okay, and further just apply. So now you find out this type of image combination, and then it create this type of images. So now we are just use this median composite image and make the land use land cover for whole country boundary of Bangladesh, and make the vegetation analysis or anything we can do using this imagery. So this visualization I want to input in my code editor. So for that I just click on the import. If you check, just click on the import, and then new line of code will be added. Just I copy and paste after the object name. So this is my object, and I paste here, and then put the layer name. Suppose bd image. Okay, and run the code. So now it will be set it. This visualization is set it in my map. Okay, so now we find out this type of imagery. So now we are just use the image and create the different types of remote sensing analysis. Okay. Okay, so I hope you can also get the idea how we can easily apply the composite, and how we can easily apply the different types of band combination, how we can easily create the single date imagery. Okay, so all of those I try to clear in this code, and you also try to use other image collection. Suppose you can see Landsat 9, Landsat 7, Landsat 5, as well as surface reflectance image collection. Same process you try. Okay, further face any problem, I'll also discuss about the solution, no problem. But same process we can apply, and then Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5, all of image collection are the same process when you filtering and displaying or creating the composite or adding the band combination. Same process. Okay, any question anyone can ask me, please. Okay, so this Dhaka boundary shapefile I already imported. Okay, Dhaka boundary shapefile you can see. So in my asset, so this is my asset, this is my own asset. So this asset I already uploaded my boundary shapefile. Okay, so you can also upload it. Previous class I discussed about that, how we can easily upload it, the shapefile boundary, same process. Okay, so simply upload your own boundary shapefile, which area you want to work, then we can easily work with that. So simply you can see the shapefile. So simply upload your shapefile. So here I already uploaded this Dhaka boundary as well as also Bangladesh boundary. So all of my needed shapefile I already uploaded in here. So further I simply use and then display the result. Okay, so you also try for other Landsat image collection. Okay, Landsat 5, Landsat 4, Landsat 1 to 5, Landsat 7, Landsat 8, Landsat 9. As well as we can also export. Suppose this type of satellite images, we can also export, and further we can also work with ArcMap or QGIS software or any other geospatial software. We can also easily work this type of images. So let's go how we can easily exporting image. Okay, so when we basically we can export that the okay, so there are the 4 types of export are available in Earth Engine. So if you simply search here export, then we find out, you can see this type of option: export image, export to asset, export to cloud storage, export to drive. So basically export to drive we are use because this satellite image I want to export in my Google Drive. From my Google Drive I simply download. Okay, so this is the option, export image to drive. Asset basically you can see this is my asset. Suppose this image I want to export and store it in my asset tab, then we need to use this export image to asset. And export image to cloud storage, Google Earth Engine is also possible to buy some cloud storage. So you can simply use this export image to cloud storage, but it's not free.